Welcome to chapter 9.8. It's our last section in this chapter, in which we're going to talk about order of operations and simplifying expressions. Now, to remember order of operations, we have a nice acronym that describes it called PEMDAS, where we say, please excuse my dear Aunt Sally. So, P is first. That is parentheses. Parentheses are always first in order of operations. And parentheses within themselves, there can be quite a few. You have the regular parentheses you're used to seeing, and usually this is a good place to start. It's not an always, but it's definitely a good starting point. Then there's the brackets, which is usually a good place to head to next. And then the curly brackets. If you ever see absolute values, treat them just like the parentheses. Simplify as much as possible inside, then take the absolute value. Be very careful, make sure you always simplify as much as possible inside before you take the absolute value. You should end up with something where you're taking an absolute value of a set number. You never take the absolute value of numbers where you got a lot going on, like 9 minus 6. You have to first evaluate 9 minus 6, in which you have the absolute value of 3, and then you take the absolute value. Don't go, oh, I'll make everything positive, so I have 9 plus 6. I don't even think about it that way. That's just crazy talk, okay? So you have to simplify as much as possible inside the absolutes before you can take the absolute value. The next step after parentheses, working with them, you go to exponents. So exponents is number 2. And exponents we've already gone over. Just make sure you have whatever your base is. If it's inside parentheses, simplify as much as possible. Then raise it to whatever the power may be or exponent they gave you. So be very careful. Make sure you simplify as much as possible inside parentheses. That's why there's step 1. Next step is multiplication and division from left to right, which is our step 3. So heading back over to that page I scooted away from. Step 3 is multiplication and division from left to right. Now, it's multiplication and division. They're occurring at the same time as long as you go from left to right. So I'm going to give you an example in which the directions say simplify, in which this rule is critical. So I'm going to write negative 16 divided by 4 times 2. If you want to, you can pause the video and try solving this on your own, how you think it should be done. And now I'm going to go ahead and solve it. So we have negative 16 divided by 4 times 2. It's multiplication and division from left to right. So you don't start with multiplication just because it appears first. You start with whatever you hit first. So going from the left, the first thing we see is division. So we have negative 16 divided by 4. So that is negative 4. And it's still being multiplied by 2. Now you do negative 4 times 2, which is negative 8. To show you how most people make the mistakes, and this is wrong. Can't illustrate that enough. This is the wrong way to do it. A lot of people get this misnotion where, oh, multiplication's first in the order of operations, so to speak, where you say M's before D in PEMDAS, so they want to multiply first. So they do 4 times 2, which is 8, and then negative 16 divided by 8 is negative 2. Which is not the same answer. It's not the correct answer either. So this is not the way to do it. You have to do it from left to right. Okay? Now, the last thing we have for our order of operations is addition and subtraction. Same deal as multiplication and division. It's addition and subtraction from left to right. So let's go ahead and see an example where they say simplify. And we're given something nice, let's say 16 minus 4 plus 2. Alright, so from left to right, starting from the left, we have 16 minus 4, which gets us 12, plus the 2, which 12 plus 2 is 14. If you were to do this the wrong way, and I don't show this to confuse you, but to show you why it is not correct, if you do 16 minus 4 plus 2, and let's say this way is really, really bad, just completely wrong. You say 4 plus 2 is first, which you get 6. And then you do 16 minus 6 is 10. Not even close, not even in the same ballpark, right? Completely wrong answer. But there is another way we can view this, and it's nice with addition and subtraction, because you can take 16 minus 4 plus 2, and you go back and you say, okay, 9.3 taught me that keep, change, change. So you keep, you change, and you change. And you have 16 plus negative 4 plus 2, in which, if you felt like it, you could do negative 4 plus 2 is negative 2. And you have 16 plus negative 2, which is really 14, which is the same answer as before. So be careful. The sign goes with its term. So that negative sticks with that 4. Alright. Last but not least, we are going to now tackle some long-winded problems that ask us to simplify, which requires us to use all of PEMDAS. And if you can just remember the order, then you are safe. So the first one we'll do is nice. We have 6 bracket 3 minus 2 times, oops, I didn't want to write times, I lied. Oops, I deleted everything. So I'm just going to rewrite it. 6 bracket 3 minus 2 times 7 minus 4. In parentheses and the bracket. Okay, so parentheses are first. We have brackets and we have parentheses. So kind of like our very first page where I say do parentheses first, then work your way to brackets, then curly brackets. That's exactly what we're going to do here. We'll start with the smallest guy, the one who's the most nested inside. So we have 7 minus 4. So if we were to rewrite this, we have 6 bracket 3 minus 2, and we're going to simplify the 7 minus 4, which is 3. Now be careful. These parentheses are here for other purposes than just to say do this part first. If there's some sort of exponent, we need to make sure we take this 3 to some power. There is no exponent. If there's some sort of multiplication going on, which usually is why parentheses are there, like here, there is this 2 times this parenthesis. So this is implied because of the parentheses. Make sure you don't just write 23, you write 2 times 3. Don't forget it. Now, we are in the still parenthesis stage. We're following order operations when we have to simplify the square brackets. So we have 6, and let's see if we can get these square brackets minimalized. Inside the square brackets, we're following order of operations. We have 3 minus 2 times 3. We're following order of operations always, so you can't do 3 minus 2 before you multiply, right? Addition and subtraction is the last thing we touch. So we're actually going to have to multiply first. We have 2 times 3, which is 6. So we have 3 minus 6. That's what these two gave us. Now, after multiplication and division, we can do addition and subtraction. So we have 3 minus 6, which is negative 3. And before we can drop these brackets, we got to see, are they important? Is there something going on? Are there exponents? No. Is there implied multiplication? Yes. We have 6 times negative 3, which gives us negative 18. And that's our final answer. Let's go ahead and do another one. These require lots and lots of practice. The next one I'm going to do is going to be kind of outrageous, okay? So bear with me as I write it down. I'm hopefully can fit it in, and it will be the last one I cover in this video. Now, I'm going to have parentheses, brackets, curly brackets, the whole 9 yards. I even thrown in X into the mix. So we have to worry about like terms when we have variables. We can only combine like terms. And we're actually going to have to use distributive law in here. So that's it. I'll stop writing. That's it of our problem for now. Okay, so when we tackle this guy, we just got to take a deep breath and not panic and go, oh my god, there's letters and curly brackets. Just don't bother with that. Go, okay. First thing I always start with are parentheses. So find your parentheses. Here's one, and hey, look, here's another one. Now it doesn't matter who you start with, because parentheses didn't care about left to right, as long as you simplify following order of operations inside the parentheses. So I'm kind of neurotic in which I need to have consistency. So I'm just going to start with the one that's leftmost because I go left to right no matter what. It doesn't make a difference. You can do what you feel like, but I'll just start left to right. Now, these parentheses on the left side, I have x minus 4. Okay. I can't combine them. They're not like terms. So I'm going to have to go, okay, well, maybe there's something going on the outside that can help me out. Is there exponents? No. Chances are we won't see those ever for these type of problems. But there is a 3 out front, and it's 3 times x minus 4. So if you remember from last chapter section, from the last section, 9.7, there is a thing called distributive law, in which you can distribute something being multiplied out front of a addition or subtraction problem, and then you can get rid of the parentheses, which is our goal here, because we can't move on until we've conquered the parentheses. That's order of operations, parentheses first. So we distribute the 3 to each term. 3 times x is 3x. 3 times negative 4 is negative 12. Now that 18 is not part of the parentheses, so it's still just the same. This is all in brackets. We still have the curly bracket, the 2. We still got this minus and this goop over here. Nothing else has changed. We've only just distributed that 3. But hey, look over at our other parentheses. We'll take a detour over there. We have 3x minus 2. Now they're not like terms, so they can't combine. We can't move on until we get rid of the parentheses, so we're going to use distributive law once more to get rid of them. So 3 times 3x is 9x. 3 times negative 2 is negative 6. And that plus 1 is still there. Now that parentheses are gone, they were there because of that implied multiplication. We can move on and say, okay, we are now in square bracket land. And square bracket land is pretty cool. It's not too bad. So we are inside the square brackets and we say, okay, can we simplify inside these square brackets? And we have negative 12 plus 18. Remember, that sign goes with the term. That's negative 12 plus 18, which gives us positive 6. And we still have 3x. So it's 3x plus 6. Make sure you write your plus sign. Don't drop it off. Now, this was in brackets. I'm going to leave it in brackets because I have to double check if there's maybe some sort of distributive law I might have to use in order to technically let it leave the brackets. So always include them just to be safe. Minus, alright, let's go over our other brackets. Same deal here, we have like terms. 9x is just 9x. Negative 6 plus 1 is negative 5. And we'll end our curly bracket. Alright, so our next step is to see, okay, I still have the square brackets, so I haven't left that phase. We're still in square bracket land. But let's see if we can drop them. They might not be important. So there's no exponent. Going out in the front, directly in the front here, there's a curly bracket and then the square bracket. So that space between there's nothing going on. So these square brackets are essentially useless. We can drop them. But let's look at this 9x minus 5. No exponents, but in the front is a negative. You can think of it as a negative 1 times this thing. And it has to be distributed to each term. So we have negative 9x. Negative times a negative is a positive 5. Be very, very careful. Negatives change the sign. Alrighty. Now, what we can do here is say the square brackets are gone. We took care of them by distributive law. Let's go ahead and combine like terms. So we're in curly brackets. Simplify as much as possible the curly brackets. We have 3x minus 9x, which is negative 6x. We have plus 6 and plus 5, which is plus 11. Now this is still in curly brackets, so I'm going to write them because I haven't gotten rid of them completely. And it's a good thing too because there's that 2 sitting out in the front, in which we get to use distributive law one more time and distribute it to each term. So our final answer is negative 12x plus 22. Your homework has a bunch of these problems. Just go very slow for them, pace yourself. Notice I wrote out every single line. Students like to drop off all their work, and that causes room for mistake. So always rewrite your entire problem. I rewrote this too every single time, even though I wasn't using him until the very end. It's important you leave it there because you don't want to forget it. I mean, you don't want to get confused by it either, but don't forget it. So try to rewrite, maybe use different colors, highlighters, whatever it may be that you need to make sure that you don't forget that 2 or some sort of distributive law, or especially the negative. So just pace yourself, take a step back, and breathe.